So we already did the first day of graphing square root functions. We should at least know that the parent graph of square root functions, y equals the square root of x, we could graph that with an input-output table. Plugging in 0, the square root of 0 is 0, the square root of 1 is 1. You don't want to use 2, you don't want to use 3, but the square root of 4 is 2, and the square root of 9 is 3, giving you this nice, beautiful parent graph. 0, 0, 1, 1, 4, 2, and 9, 3, right? Maybe up there a little more. So this is what it looks like. And all other square root functions come from this guy right here, right? Yes, it might get reflected over the x-axis. It might get vertically stretched. It might get vertically compressed, right? It has different transformations. But the bottom line is, this is where it begins, and you end up somewhere else, right? Now, if for some reason your a value on your given function is 1, just like this parent graph, you could actually go to the beginning point, hk, and use this pattern 1, 1, 4, 2, 9, 3. It's kind of like the pattern of parabolas, but backwards, or switched. The parabola pattern was 1, 1, 2, 4, 3, 9. Right here it's 1, 1, 4, 2, 9, 3. Okay? So, comparing parabolas to what we're doing now, back then in semester 1 when we did y equals a, the a told us whether it got reflected over the x-axis. Does it open up? Does it open down? In addition to that, it tells us if it got vertically stretched or compressed, right? The h value always tells you whether it shifts to the left or to the right. And the k value, it always tells you whether it shifts up or down. And of course, h and k on parabolas was the most important point. That was your vertex. Right here on square root functions, it's the same deal. Everything tells you exactly the same as parabolas. The a value still tells you if it reflects over the x-axis. It still tells you if it vertically stretches or compresses. Same thing with h and k. Those are the shifts. But the coordinate hk is no longer a vertex. It's now an end point, or the beginning point, whatever you want to call it, when you graph that square root function. Let's jump right in to Desmos. I would like you to graph this first function right here, y equals the square root of x, which is the parent graph, okay? So type that in, y equals the square root of x, and you should see this graph that I'm showing right here, okay? Now, you may have to zoom in to get these actual coordinates to be single units. I would like you to have single units shown, okay? It'll make a world of difference. So if you're looking at your graph and you see this first one saying 2 and then 4 and then 6 and then 8, zoom in a little bit so it could change to a 1, 2, 3, 4. So everybody please graph that parent graph. Go for it. So I see that everybody has that. What I want to do now is for you guys to put a negative right in front of that square root of x. Put a negative in front of the square root and see what happens. So that's what you should see right there. When you type in that negative in front, it reflects over the x-axis. What used to be up here now got reflected on the x-axis. So it's opening down now, okay? So you know what? Let's go back to the original parent graph. Go back to the y equals square root of x. And what I want you to do right now is to type in Desmos, type in, let's say the number 2 right here. And what do you think is going to happen? It's going to vertically stretch by 2. Go ahead and type in a number 2. And this is what you should see now if you type in the 2 right there, right? Now, of course, if you're not seeing this exact type of shape, please zoom in enough so you could see the 1, 2, 3, 4. I don't know, if for some reason you're seeing like 10, 20, 30, that's not good, right? Zoom in enough to see 1, 2, 3, 4. That's good. So if we look from the beginning point right here at 0, 0, how many levels? Well, first of all, am I going up or am I going down? I'm going up, which means that my a value is positive. Now, how many levels up do I have to go in order to get to the next clean point? 1, 2. You see how this is a nice coordinate right here? Right here it's not a nice coordinate, but right here it is. So this is a trick, all right? It's not the slope. I mean, yeah, it kind of reminds me of rise over run, but it's a little trick to be able to identify what your a value is when you don't know it. So if you're looking at a graph and it's actually going up, that's a positive a value. And if it goes up 2 units before getting to the next nice coordinate, then your a value must be positive 2. Okay, go ahead and change that 2 to a 3. So you should see this right here, right? And once again, this is the connection I want you to make. From the beginning point, it's going up, so the a value is positive. Yeah, it's positive 3, but how many units does it go up before it gets to the next nice coordinate? 1 level, 2 level, 3 levels. Does that make sense? That's not a coincidence, guys. If this is a 3, it's going to go up 3 levels before it gets to the next nice coordinate. Does that make sense? Okay. Now, what if you were to put a negative sign in front of it? Then it would just simply be going down 1, 2, 3, and then over 1, and going down this way. Does that make sense? Yeah. Okay, great. So I hope we understand how the a value affects our graph. Okay, and I hope we're able to identify the a value just by counting from the beginning point and seeing if it's going up or down and seeing how many levels it goes up or down to get to the next nice coordinate. That way we could identify our a value given a graph. So it goes back to this. The a value tells you a lot. The h is simply your left and right shift. The k is your shift up and down. And of course, hk is the most important point. It's the end point or the beginning point if you're drawing it, right? So what I want to do is get so comfortable with this that we're able to look at a graph and be able to come up with the actual equation. Now, back when we did this with parabolas, if I gave you a parabola, I wanted you to identify 3 specific values. Those values were the a, the h, and the k. If you're able to identify the a, the h, and the k, you're able to write the equation simply by plugging it into this format. Same deal here with square root functions. Let's look at a graph. Let's identify a, h, and k, and let's write the equation. Here we go. So let's take a look at this guy right here that has this endpoint that's going down instead of up, so that should tell you something about a. I want you and a partner to talk about this. Try to identify your a, your h, and your k, and try to write the actual equation that would produce this guy and verify it by typing it into Desmos and seeing if you could actually get the same exact graph. I want to pause it. Go for it. All right, because it's the first time, and you guys, the people that showed me you guys already got it, right? A couple of you already got it. That's awesome. But this is the first time. I don't expect not even half of you to get it, which is that's normal. This is what we want. We want y equals a square root x minus h inside the square root. The plus k, you want it on the outside, right? The plus k on the outside of the square root. You don't want to type it on the inside. K is always on the outside by itself. Okay, so the question is, do we know the a, the h, and the k? If we know the a, the h, and the k, we are ready to write the equation. So the a value, here's your beginning point. Does it go up or does it go down? Down. So I know a is negative. So it goes down, but how many levels does it go down before getting to the next nice coordinate? 3. So that means that a is negative 3. Again, that's just a little trick. It's not like a slope. It kind of reminds me of slope, right? Down 3 over 1. So the a value is negative 3. But it's not a line, it's a curve, obviously. And it's definitely not, it doesn't continue to go down 3 over 1. That's not the case. It's only from your first beginning point to the next actual nice coordinate, down 3 over 1. So it goes down 3 levels, so the a value is negative 3. The h value and the k value is from the most important point right here. Now, we are so used to saying, oh, think opposite on h, but don't think opposite on h when you're looking at an xy plane. What is that coordinate right there? Negative 2 comma 6, that's exactly right. And that coordinate is your h and your k. So the h value is negative 2, the k value is positive 6. Once again, the h value is not positive 2, the h value is negative 2. When do we think opposite? When we actually see an equation and we want to pull h out of there. So let's plug in all these values. We have y equals a square root of x minus h plus k. So the a value is negative 3. The h value is negative 2, and the k value is 6. And this is why we think opposite on h, because the minus 2 changes to plus 2. So this is the equation that you want to type in. Y equals negative 3, square root of x plus 2, and then a plus 6 on the outside. Sound good? Okay, so that was the first time. I hope we kind of understood what I just did. Let's have you guys try it again. let's check this one out. I know you're thinking, wait a minute, we just did that. No, it's a little different, right? Yes, it has an endpoint right here. So go ahead and talk to a partner. Try to figure this out. Try to get it on Desmos. See if you could get it. So obviously, if you're zoomed in too much, or if you zoom in just on the Y's or just on the X's, it's going to change the way it looks. It won't look exactly like mine. But this is what we want. And let's figure out what each of these values are. Well, the A value from here, is it going up or is it going down? It's obviously going down. So how many levels does it go down before it gets to the next nice clean coordinate? 2. So the A value must be -2. Okay, and the H and the K is the coordinate what? -3, +4. So your H is -3, your K is +4. Now let's just plug it all in. Y equals square root X minus and then plus K at the very end. The H is -3, the K is +4, and the A value is -2. All you have to do now is simplify the minus minus into a plus plus, and you'll be good to go. Y equals -2 square root of X plus 3 plus 4 on the outside. What do you think? How does that feel?
Pretty easy.
Pretty awesome, right? Okay. So it's all about practicing. If you're not practicing, then you're not going to get good at this, right? You want to practice, so on the quiz, you're able to answer these questions very, very easily. Okay. How about this guy? I want to pause it. I want you guys to try to get this graph on Desmos by identifying the values that you need. If you look at the beginning point, how many levels does it go down before it gets to the next nice coordinate? 1, 2, 3. Does that make sense? So it's going down 3. That must mean that the A value is -3. So as you're typing it in, Y equals, you're going to put -3, and then you have the square root of X minus H. Where are we going to get HK from? From this beginning point, the H is -3, the K is -1. So you're going to plug in a -3 right here and a +1, or not a +1, a plus -1 on the outside of the square root. So make sure you don't extend that square root over the -1. That's not good. To write it in simplified form, it would be Y equals -3 square root of X plus 3 with the -1 at the very end. Okay, so this is the equation that we want. Okie doke? Okay, let's go back to our worksheet. This is what we were graphing by hand. Now, we take a look at the back side. Take a look at the back side of the worksheet. We have homework problems right there, and this is graphing by hand. I don't really want you to use an XY table anymore. You could use Desmos, but check out how easy it is. It's even easier to graph this without Desmos. See, I already know that all square root functions come from the parent graph. Y equals the square root of X. So the square root of 0 is 0. The square root of 1 is 1. The square root of 4, 1, 2, 3, 4 is 2. And the square root of 9 is 3. Now, that's what my parent graph looks like. This guy right here has an HK of -4, -5. So my beginning point is at -1, 2, 3, 4, 1, 2, 3, 4, 5 right here. And it has the same pattern as the square root function on my parent graph, right? So it would be like the square root of 1 is 1, so I'd put a dot right here, and then go back to the beginning point. The square root of 4, 1, 2, 3, 4 is 2, put a dot right there. Does that make sense? And then the square root of 9 is 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3. So there's my actual graph. Of course, you could have done that on Desmos, but I just did it without doing any real math. Okay, you know what? I would like you to type this into Desmos. This guy exactly the way it is. And now I want you to, instead of typing it in with an equal sign, I would like you to do y is less than the square root of x plus 4 with the minus 5 on the outside. What do you think that's going to do if you put a less than instead of an equal sign? It's going to shade where? The bottom of it, right? And it's going to be it's going to be a dotted line. So you're going to have a dotted line like this, and it's going to be shaded below. So you guys could verify that right now on Desmos. If you put a less than right there, it's going to be shaded below. It's going to be a dotted line. Now, if I had an or equal to, then it would be a solid curve going like that. Wow, that's ugly. But you get what I'm saying, right? Okay, so the final little twist here is to understand the shading. If it's shaded below, it's less than. If it's shaded above, it's greater than. So with that said, let me give you a graph. All right, guys, so what you guys should be doing is identifying that the a value is -1, because from here it's not going up, it's going down. And how many levels does it go down before it gets to the next clean coordinate? It goes down 1. Whoops, I had my mic off. Sorry about that. So once again, the a value, it goes down 1 unit before it gets to the next nice coordinate. So the a value is -1. Okay, if it would have gone down to here, then it would have been -2. If it would have gone down to here, then that would be -3, right? So that's how you figure out your a value. It is negative. Now the h and k is 0, 2, which means your h is 0, your k is 2. That's the beginning point right here. So you could all plug it into y equals a, -1, square root of x minus h. There is no h, well, you could put 0 for h, and then plus k on the outside, plus 2 on the outside. So the simplified version of this is y equals negative square root of x plus 2. Let's try one more. Okay, that one looks crazy, huh? It has a beginning point right here. It is a little funky. But if you identify the a, the h, and the k, you will be able to come up with this curve. And if you want to shade above, you know what to do. Instead of the equal sign, you're going to put that symbol. I want to pause it, work on it. Let me know when you get it. Ladies and gentlemen, this most important point, hk, is -1, -5. And from the beginning point to your next nice coordinate, you're going up, not down. So the a value is positive. +1, +2, +3, +4. Right? That's how I get to the next nice coordinate. I'm going up 1, 2, 3, 4 levels to get to this next nice coordinate. So the a value is +4. So we could plug it into y equals a square root of x minus h plus k on the outside. So we have y equals square root of x minus h plus k on the outside. The a value is 4. The h value is -1. The k value is -5. So you could change the minus to plus, and you could also change that plus minus to just a regular minus. So y, now instead of equal, the equal sign would just give me a line, a curve, right? But we want to shade above that curve, so I have to put a greater than symbol, okay? And then we have the 4 square root of x plus 1 with the -5 on the outside of the root. So I hope we understand that, because these are the types of questions that we will have also on the next quiz.